Hello everyone, hope you all are doing well. So today we are going to discuss the next topic of our geography series, and the theory we are going to discuss today is plate tectonics theory. Okay, and in the previous videos we have already discussed the theories, that is continental drift theory, conventional current theory, sea floor spreading theory, and today we will be discussing about plate tectonics theory, and this will be the last theory. Okay, so let's start. And before starting, I must let you know that please do make notes. Okay, because if you make a good notes, it will be very helpful for you during your revisions. Okay, so please do make notes and do revise them. So let's start the plate tectonics theory. So this theory was given by Parker, Mackenzie, and Morgan. Parker, Mackenzie, and Morgan in 1967. Okay, it also uses conventional current theory to explain its movements. We have already discussed conventional current theory, so if you don't know, please do revisit that video and see that video. You will know the concepts of conventional current. So it uses conventional current theory to explain its movements. To explain its movements. So actually, there are two parts in this theory which are responsible for movement. First part is the geometrical part, and second one is the kinematics part. So what is this geometrical part? Or geometrical part is that here we have to locate and map different plates. Okay. So first in this theory, what these three guys, that is Parker, McKenzie, and Morgan, have done, that they have located various plates. So locating and mapping different plates. And in second part, we have to understand the plate movements and associated geophysical phenomena. In kinematic part, we have to understanding. There should be understanding of or understanding plate movements and associated geophysical phenomena and associated geophysical phenomena. So these are the two parts, that is geometrical part and kinematics parts. So let's first discuss the geometrical part, that is let us locate and map different plates. So I have previously made a rough world diagram of world. So we will see where are different plates located. So the first important plate is this North American plate. North American plate. So this plate is known as North American plate. Then we have South American plate. South American plate. So this portion will come in South American plate. Then here we have Europe, and it is Eurasian plate. This portion is Eurasian plate. And do remember that India is not completely part of Eurasian plate. Okay. So it is Eurasian plate. Here Africa, we have African plate. African plate. Then here we have Indian plate. Indian plate. This complete region will come in Indian plate. Okay. Then we have Pacific plate. This region is known as Pacific plate. That is the Pacific Ocean plate. This will be the Australian plate. Australian plate. How many we have done? 1, 2, 3, 4, 5, 6, 7. One more, that is here Antarctic plate. Antarctic plate. So these are the 8 major plates. Okay. So what we have discussed just now, these are the major plates. There are certain minor plates also. So we'll also discuss those minor plates. So when we come to minor plate, so they are base minor plates, we will locate them. Here you will get Japanese plate, okay, number A at the end of here. Here it is Japanese plate. Then below Japanese plate we have Philippines plate, let it be B. B is Philippines plate. Then we will look at another plate at the northwest part of America, C. Here C is Carolina plate. Carolina plate. Then D here in the western parts of, sorry, northeast Australia. This was here the western parts of North America. We will have Juan de Fuca plate. Juan de Fuca. If you see Juan de Fuca plate. Then in the western boundaries of South American we have Nagza plate. E is Nagza plate. Then here in the south eastern part of Southern America we have Scotia plate. Scotia plate or Scotia plate. Scotia plate. And G here in between Indian and African plate you will find Arabian plate. G is Arabian plate. And here these island arcs which you can see is H. H is the Burmese plate. So all the things which are denoted by yellow are the major plates, where the gray ones are the important minor plates which have been mentioned here. So do make this a map and do remember these plates. These are very important. Now this was the geometrical part of the plate tectonics theory. Now let's move to the kinematics part. Okay. Kinematics part. So as per kinematics part, there are two types of plate. First one is the continental plate and second one is the oceanic plate. The continental plate is dominant in granitic rocks. Here you will find that they are dominant in granitic rocks, whereas oceanic plate is dominant in basaltic rocks. We know that a lot of basalt come out from mid-oceanic ranges. Okay. Then this was the types of plate. Now there are three types of plate boundaries. Three plate boundaries. So the first one is here diverging plate boundary, which is also known as constructive. Diverging, that is going apart, that is going away from each other. Then we have converging plate boundaries. Converging plate boundaries, that is destructive. So in converging, two plates are coming together or coming towards each other. Now next one is the sliding or transform boundary. Transform. So here two plates transform, slide against each other. They do not interact, but they slide. Suppose this goes this way, this goes this way. So these are the three types of plate boundaries. Now first we will see about diverging plate boundaries. Diverging plate boundaries. So here there are 4 stages of geophysical formations. We have to discuss about physical formations because in kinematics part we have to look into the geophysical formations. So in the first stage there is intracrustal thinning, that is the crust starts to thin up. We are discussing about diverging plate boundaries. Then second stage is the rifting. Okay, rift will start to form. Then in the third stage, this is second stage, in the third stage you will see that the formation of mid-oceanic ridge. Formation of mid-oceanic ridge. So what happens? First of all, crust gets thinned up, then this thin starts to become a ridge, and from this ridge the mid-oceanic ridge are formed, and then from this ridge volcano erupts and they start to spread. Number 4 is the sea floor spread. And in the seafloor spread, you will find the formation of new ocean crust, or the formation of new ocean or new ocean crust. So this is about diverging plate boundary. Now let's go into converging plate boundaries. Converging plate boundaries. Actually, converging plate boundaries of three types. First one is the ocean-ocean convergence, when the two plate boundaries which are oceanic converge amongst each other. Then we have ocean-continent convergence. Then we have continent-continent convergence. So first, let's discuss about ocean-ocean convergence. Ocean-ocean convergence. So here we will see the best example is the Japanese and Pacific plate. Japanese and Pacific plate. When you see the diagram, you will see that the Japanese plate here is also located in the ocean only, and this Pacific plate is also ocean only. So they start to converge. Okay. So this is the best example. So in ocean-ocean convergence, in the first stage, you will see the formation of trench. Trench formation. In second stage, you will see the formation of volcano arc or mountains. Formation of volcano arc / volcanic mountains. In the third stage, you will find the formation of sedimentary arc or fold mountains. Formation of sedimentary arc or fold mountains. Fold mountains. And in the fourth stage, you will see the formation of island arc. So always remember that island arc generally most of the times is formed due to convergence, and that too also of ocean-ocean convergence. And when you go to examples, there are various kind of island arcs which you can form. We are giving examples of such some island arcs, and there's a high chance that this could be asked in direction wise. So this is our Asia. So here you will find 3-4 island arcs. First island arc will be here, then we have second island arc, then we have third island arc, then we have fourth there island arc. So this first island arc is obviously Elysian island arc. This first one is the Elysian island arc. Second one is the Japanese island arc. Third one is the Philippines island arc. And the fourth one here is the Indonesian island arc. So do remember them north to south. Okay, these island arcs, north to south, there are high chances that this could be asked. So from north to south, when you go to the islands, first we have got Aleutian Islands, then Japanese Islands, then Philippines, then Indonesian. This is north to south. So do remember it. So this was about ocean-ocean convergence. Now let's see ocean-continent convergence. Ocean-continent convergence. So the best example you can observe here in ocean-continent convergence is Naga Plate and South America Plate. Sorry. Naga and South America Plate. Let me show you the diagram. So this is here Naga Plate, and this is the South American plate. So South American plate is a continental plate, whereas the Naga plate is an oceanic plate. So here these two converge. So we will see the stages. In the first stage, there will be formation of trench, obviously. In the second stage, volcanic arcs or mountains form. Volcanic arcs / mountains. And in third stage, there is formation of special fold mountains. Special fold mountains are formed, and the most common example of this special fold mountains is Andes. And these special fold mountains are also known as Cordillera. So Andes is an example of a Cordillera. That is Andes you will find here, here in the west coast of South America. So that is how they are formed. So this was about ocean-ocean convergence. Now next we have continent-continent convergence. Continent-continent convergence. So example, the best example is the Indian and Eurasian plate. Indian and Eurasian plate. So this is here Indian plate. You can see them. It is continent only. This is the Eurasian plate. So these both converge, and here we see the formation of Himalayas only. So we will discuss that. So in the first stage, there is a fusion of continents. So one thing you should remember that here is no subduction. In trenches you see subduction, but here is no subduction, so no trench is formed here. Keep it in mind. So here you will see instead of subduction there is fusion of continents. In continent-continent convergence, there is fusion of continents, and it marks the last stage of convergence. Marks the last stage of convergence after ocean and ocean continent. Ocean and ocean continent. Obviously, in ocean, one landform will be formed at the end, either island arc or something. In ocean continent, obviously, both the landforms will be formed. And in third part, you will see that there is last stage. You will see continent-continent convergence. So this will be the third stage. Now the next one is the transform or sliding plate boundary. Transform / sliding plate boundary, and this you can see in the Australian and New Zealand plate. Australia and New Zealand plate. So another example could be Javan de Fuca and North American plate. So here you will see the convergence. Slide. So you will see that here we have Javan de Fuca plate. Number D. Sorry, here. Here you have Javan de Fuca plate, and here this is the North American plate. So instead of converging, they slide against each other. So it is the best example of sliding or transform boundaries. So this was about the geophysical part, or you can say kinematics part. So this was the two parts about the theory which you have to understand. I have given the examples also, and I think you would have understand all this thing nicely. So that is all for today. If you like it, please press the like button. Please do share, and please do subscribe. It takes a lot of hard work to make such videos for you on regular basis, and if you like, if you share, if you subscribe, it motivates us to make more such videos for you regularly. So that is all for today. Have a nice day. Thank you.